So guys, this is a interactive single line diagram which is exactly replacing or depiction of a single line diagram which we have seen in a PDF, and I will tell you something especially about this single line diagram. Actually, this is the same which is being used in the modern substations in the control room or in the control center of the centralized control center for all the substations. This is called human machine interface. Modern substations, SAS substations, the SAS engineers are developing these kind of single line diagrams through softwares, and there are the SAS substations in Kingdom, Saudi Arabia, Siemens, ABB, Cell, and Alphanar. They are producing their single line diagrams, their HMIs, and this is a specific job opportunity in the kingdom, especially for designing such single line diagrams and cosmetics in the control systems. But they are very expensive actually. So to give you this concept, actually I tried a lot and I did more efforts. I tried to find first this application from the Google Play Store or the normal search engines. I could not find a simplified application which is readily available and answering our concepts and questions. So you will be glad to know that when I did not find anything, I developed it by my team, my IT engineer, Mr. Ghulam Abbas. He supported me, and Mr. Hamza, he supported with the cosmetics of this and the designing of this single line diagram. So now the beauty of this one is that you can play with this one. You can open, close, you can do the wrong operations, and the dialog messages will come telling you that you are doing wrong. And this is the beauty of the interlock. So I have tried to implement the basic interlock here, but the advanced interlocks will depend on your requirement at the site and the project. So but this is actually covering the 90-80% of the interlocking concepts. So here the single line diagram is basically containing a 2 bus bar and one feeder, line feeder, which is connected with XLP cable and SF6. This red, this filled black and this white is showing actually this termination is having an interface of XLP oil and SF6 gas. So starting from here, this is the voltage injection point giving you option of 110 and 380 kV. How interesting is that? And practically you have to arrange the injection kit, but here you have to just select 110 and 380 kV because this is a simulation for learning purpose. Whatever we will inject, we will read it here in the digital function meter. Digital function meter is reading the voltages and currents and everything, but here I have only used the voltage functionality to just give you a brief of how the things are working. This is the legend part showing the designations and their functionality. So according to the truth table, you can make the correct operations. But before making the correct operations, let us do the wrong operations and let us see if interlocking is working or not. For example, now this we have injected and the red line is there. Okay, you can see if we put 0, this is our blue, means unenergized. When we are putting it 110 kV, it is red. Do you think that this Q8 will be closed if this line is energized? You try it. It will give you a dialog message that you must open Q8 you must open Q8 to close, must open Q9 to close Qn, and injection point voltage must be 0. It is not 0 here, it is 110, so this cannot be closed. I will make it 0. Now I will try to close the earth switch. It is closing. Okay, so this is a interlock is working there. Okay, if Q9 is closed and now I want to close this Q8, it will give you again error. So because the condition for Q8 is that Q9 should be open and this should be 0. So let us now see the other interlock, Q1. Q1 can be open and close according to the truth table. You can see here, okay, and you can see here it is not allowing to close both together because this is exclusive or. So any one of them can be closed, but one at a time. So let us close the circuit breaker now. If I have closed the circuit breaker, it is saying you cannot close because you are not meeting the criteria. What is the criteria for the circuit breaker to close? open Q8, which is here, close Q9, which is not yet met, and close Q1 or Q2, not both. Then you can only close the circuit breaker. Let us try it. Q9 is closed, Q1 is closed. Now let us try that this circuit breaker is closing or not. I believe it should open, but note one thing, that we have not injected the 110 kV voltage. Let us inject. So now our 110 voltage is appearing at this end of the circuit breaker, not at this one. Once the circuit breaker will be closed, the power will flow, voltage will flow, and this will be read by this VT, and the meter is connected here. So let us close. Congratulations, now you have energized through one feeder for bus 1, bus A. So this is a very good achievement when you are actually energizing the substation. I have witnessed it by myself. This very exciting day when the substation is going to be energized. You will feel it once you will be in a real substation and you will energize it, and you will remember these words. This type of same single line diagram, you will find it in HMI of millions of dollars, okay, and you will feel that you know it before you reach there. So this was the effort to give you some knowledge. Similarly, now you can open, we have done the closing operation of circuit breaker and disconnector. Now we have to do the open operations. Same way you can follow this truth table which is showing in the screen for the opening of the circuit, this operations. Let us do the wrong things first, okay. Now this line is energized. I will open the Q1. It is not allowing because Q1 is a disconnector and it's a no load device. If the load device will be operated on the load, it will be damaged. And circuit breaker is an on load device. So circuit breaker can trip and close under normal and fault conditions, but not the disconnectors. These disconnectors are off load device. They are when the current is zero, then these devices can be operated. So what is the correct sequence of opening the circuit breaker? First thing, this all should be closed, Q1 and Q9, and the first thing in opening operation, you have to open the circuit breaker. So we will open it here. Must open Q0 to open Q9. Okay, this Q9 is not allowing to open because this is also offloading. So Q0 will open. Now you can see that light turn, this color turn to be blue, and the circuit is de-energized and circuit breaker is open. Now you can open the Q9. You can remove the voltage, you can normalize, you can close the Q8. So this is a basic principle. You can try both truth tables when you will get this application, but this application I will give you once you need it. If you really need it, by your comments, by your subscription, then I will provide you the guideline how to get this application, because this is a locally developed, not available in any store. If you find any application developed and available, please share with in the group so that people can also be get the benefit for that, and we will not spend more time in developing such applications, and we will directly go to the concepts. Hope you like this interactivity of this topic, and let us proceed to closing this video. Thank you for watching this video. I hope you have enjoyed this interactive SLD. Kindly answer the following questions in the comment section. Question number 1, which I have discussed: if we close Q1 disconnector switch after closing Q0 circuit breaker, technically what is the wrong with this operation? Question number 2, tell me sequence of operation if we want to energize bus 2 instead of bus 1. And also let me know that you are interested in getting this simulation application to try by yourself. You can contact me at this given address. Thank you.